Hello students, welcome to memoneets. I'm Faguni, your chemistry SME. So let's begin with today's question and answers. So the first question says, oxides of nitrogen contain 63.65, 46.69 and 30.46% of nitrogen by weight respectively. The data illustrates the law of what is ours? The data that illustrates the law. Which law is being illustrated? This is law of multiple proportions. Why? Let's see. What does it states? It states that when two elements combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in ratio of small whole numbers. Though both these compounds, these are in ratio. So the different percentages of nitrogen in oxides indicate that the compounds are formed with oxygen and mass of nitrogen that combine with the fixed mass of oxygen. We have nitrogen, we have different masses of nitrogen, and we have oxygen of fixed mass. These combine in equal ratio, which aligns with law of multiple proportion. Let's see how. Firstly, these are the following percentages that are given to us for nitrogen. So what we will do, we will calculate the mass of oxygen and nitrogen respectively. So for that, we'll assume that we have 100 grams of each oxide and we'll take what is given to us. 63.65 is given. Then out of 100, 63.65 of 100 would be 63.65 itself. And for oxygen, we will subtract this value and we will get the mass. Now for the second oxide, we'll repeat the same procedure. And for third oxide as well, we'll repeat the same procedure. Now what we will do, we'll calculate the mass ratio of oxygen to nitrogen. For that, we'll divide these. For the first oxide, ratio of oxygen to nitrogen would be mass of oxygen divided by nitrogen that we get is 0.57 gram. Similarly, we'll do for second and the third oxide. Now what we will do, we will normalize this ratio. For doing so, that is, we want it that each should be similar. So we'll divide it by this value and we get point 0.51 and 2. Now we have to convert this into whole number. For that, what we will do is that we will be multiplying these numbers by 2 because we need the nearest whole number. So what we get 1, 2 and 4. Therefore, this is the simplest ratio. So the answer would be multiple proportions. I hope that's clear. Now let's see the next question. The percent of copper and oxygen in the samples of CuO obtained by different methods was found to be same. This proves law of see what is given that the percent of copper and oxygen in samples of CuO, and we did different methods to find the percentage, and but they came out to be same. So what does this indicate? These have constant proportion, right? The answer would be 1, which states that chemical compound always contains the same elements in exactly same proportions by weight or mass, regardless of the sample size or the method of preparation. Here, what is given? Method of preparation. So the statement says that it does not depend upon that. It will remain constant, the percentage. Now let's see the next question. Which of the following represents Avogadro's hypothesis? What is Avogadro's hypothesis first? That equal volume all the gases under the same condition of temperature and pressure will contain equal number of molecules. So they will contain equal number of molecules, right? So let's see which of these statements states that. Out of these, statement 2 says what we need. That is, equal volume of gases under the same condition of temperature and pressure contain an equal number of molecules. The next question says the increasing order lowest first for the values of E by M, that is charge by mass ratio for electron, proton, neutron, and alpha particle is. See what we have to do. Neutron. Let's see for neutron. This has no charge. This is neutral, right? So it's E by M, that is charge by M would be 0 by M, that is 0. Now for alpha particle, that is when we take helium for alpha particle, it has a very high mass, okay, compared to that of proton and the electron. If mass is high, you can see that if mass is high, then to maintain the ratio, E should be less, and proton and the electron have same charge in magnitude. One is plus, one is negative. I'm talking about the magnitude. So what would be the correct answer? N, alpha, P and E. That is this, right? Because in neutron, then we had alpha and then P and E. Let's see. The increasing order lowest from 0 to E a bit lesser because we observe that, and then P and E they have same. Now the next question says, which of the following statements in relation to the hydrogen atom is correct? Statement 1 says 3s orbital is lower in energy than 3p orbital. 3p orbital is lower in energy than 3d orbital. 3s and 3p orbitals are lower energy than 3d. The last option says 3s, 3p, and 3d orbitals all have the same energy. Which option is right? Let's see first the explanation. What is hydrogen atom? This is 1s1. It doesn't mean, first of all, that some of you might be wondering why it has 3s orbitals or 3p or 3d. It will have all the orbitals. It's just that they are not filled. Hydrogen is 1s1, right? Hydrogen atom we are talking about. So that is why they will have all the higher shells. Now what happens is electron is filled only in the 1s orbital, and other upper orbitals that are higher in number, what happens to them that they are not affected by it, so they have the same energy, no repulsion or degeneracy is lost, so they will have same energy as all the orbitals belonging to the same cell have same energy in hydrogen atom. There is no electron in third orbit, thus all are equal energy, so the option D is the right one. The next question says, when beryllium is bombarded with alpha particles, extremely penetrating radiations which cannot be deflected by electric or magnetic fields are given out. These are, we have to tell which of the one is the correct. Firstly, read the question correctly. What is given? That the particles or any of the given particle cannot be deflected. When which case it won't be deflected? When it is neutral or it is chargeless, right? So what would be the answer? Obviously, it would be a beam of neutrons because these have positive charge, these have a positive charge, and this also. Moving to the next question. The total number of neutrons in di-positive zinc ions with mass number 70 is. Okay, let's see this. How we will do it. It is given that the mass number of zinc is 70. So, in case of zinc 2 plus, it won't change. Mass number is not affected by protons or neutrons or ions. What is the atomic number? Z is represented for atomic number, which is 30, zinc, 3d10. So it is 30. Now what is being taken out? Protons, right? And no effect on Z is there with the protons. No effect. So what we will do to find the number of neutrons, mass number will be subtracted by number of protons, which gives us 70 minus 30, that is 40. So the correct answer would be B. Now the next question says, this is a very easy question. The wavelengths of two photons are 2000 angstrom and 4000. What is the ratio of the energies? What is the expression for energy that we have? That is h nu, or we can say it's c by lambda. So you can see that it is inversely proportional to lambda, right? So how we will be expressing it? For example, if we have even by E2, then we can take it as lambda. Oh, wait, so it would be lambda 2 by lambda 1. So it would be 2000. If we are considering 1 to be 2000 upon 2000, it would give us 2. So the correct answer would be D. Now the next question says the bond length between the hybridized carbon atom and the other carbon atom is minimum in. See, in case of we have sp3, we have sp2, and we have sp. So the bond strength and the bond order would be this. So what will be the case in bond length? It will be the reverse. And what is asked is minimum bond length, which is of sp. We have to see which is an alkyne here. That is propine. So it would be the correct answer. Now let's see the next question. Hybrid state of sulfur in SO2 molecule. What is the structure of SO2? This, right? What does it look like? It is obviously planar structure, trigonal, and it is sp2. Whereas one thing to note is that the angle between this is not exactly 120, it is less than 120. Why? Because due to fluent repulsion, A will come closer. Alright? So that is the correct answer, sp2. The next question says, among the following, the maximum covalent character is shown by. See, whenever you see covalent character, always remember that you need to use Fazan's rule. What does it say? Smaller the cation, larger the ion. We have more will be the covalent character. So, smaller cation means it must have greater charge, positive, right? You can see here, this is Mg2 plus, this is Fe plus 2. Because this, see how I got to know that it would be plus 2. You can see, it must have been formed by cross valencies, right? This would be Sn plus 2 and this is Al plus 3. Now, according to this one, this statement, which should have a greater positive charge, aluminium plus. So that is the correct answer. So then the next question says, among the following mixtures, dipole-dipole as a major interaction is present in. For dipole-dipole interaction, we should have polar molecules. Polar molecules have dipole. Okay. London forces are there between non-polar. Dipole-induced dipole is between a polar and a non-polar. Okay. See, benzene. Keep this in mind that benzene is non-polar. Okay. So let's see which could be our answer. As I said, benzene is non-polar and CCl4. It has this structure. So what happens is it is symmetrical tetrahedral geometry. So the London forces are the major interaction because both are non-polar. This and benzene. And In option one, you see you have ethanol. This is polar, we know it has OH. And benzene is non-polar. So again, there will be dipole-induced dipole interactions. I told you that. Option B says acetonitrile and acetone. What is acetonitrile? This is CH3CN, acetone is CH3, COCH3. These both are polar. Okay, so they will have dipole-dipole interactions, which is our correct answer. Let's see what is said in option C, KCl. We all know this is an ionic compound, so it would be ion. Water is a polar compound, so it would be ion dipole interaction. All right. The next question says, how much copper will CuSO4 solution release when 96500 coulombs of electricity is passed through it? What we will use here, Faraday's law. That is the key concept here. Okay. So let's see how we will solve this. See, firstly, what is the electrolysis reaction? It is this. You can see the oxidation, the N would be, the number of change would be 2, right? And then what we will use is, what is Faraday's law? What is Faraday's law? What we use, wait, see. Now we got N equals to 2. That is 2 moles of electron change is taking place. Now using Faraday's law, which states that the amount of substance deposited during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. The relationship can be expressed as this. Okay? Upon putting the values, we get zero point 0.5 as the moles of CO. But what is asked? Mass is asked. So what we will do? We will convert this. That is, we will multiply this mole into its mass, that is 63.5, which gives us 31.75. That would be our answer. Right? What is F here? That is Faraday's constant, which value whose value is 96500. According to the next question, the two most frequent elements of an electrochemical cell are cathode and anode. Which of the aforementioned statements regarding the cathode is true? See, one shortcut trick I'm telling you here, it is, keep this thing in mind. LOAN. Okay, loan, which says left side oxidation. This is for electrochemical cell. Anode negative. That is, we have anode on the left hand side, oxidation takes place and it is negative. So keep this thing in mind. Now the opposite will be for cathode. Now it is said cathode is where oxidation happens, which is obviously false. We know why. Electrons enter cathode. This seems to be right because reduction would be there, and when what happens in reduction, electrons are there. Electrons are received. Typically indicated by negative sign. No, we know now. We know this expression, which is very important. So that is why D is the correct answer. Now moving to the next question. Electrochemical cells follow one of the following rules. The cell potential is a broad characteristic. Cell potential is an important intense characteristic. In electrochemical cells, Gibbs free energy is an intense attribute. Gibbs free energy for an electrochemical cell is undetermined. See, what is broad and what is intense? What is intense means it is not affected by amount of the material, not affected. But broad is affected. Okay, so cell potential is unaffected by it. So it is intrinsic. But what happens in case of Gibbs free energy? It depends on the amount of material present, so it is a broad feature. So what would be the correct answer? Cell potential is an important intense characteristic. Moving to the next question. How long would it take a 100 ampere current to deposit 50 gram of aluminium from an electrolytic cell containing Al2O3? Let's see. The reaction would take place as this. So we have N equals to 3. How we will get equivalent mass? By dividing molar mass by N. That is, aluminium has 27, then by 3 we have 9. Now we need to use the formula W equals to ZI2. Okay. Now we have W, we have Z, equivalent weight upon F. Then we have I and T. We'll just substitute and get the answer. That comes out to be 1.42 R. Now we converted this by dividing this value by 60 into 60 minutes and per hour, right? So the next question now says mole fraction of glycerine in the solution containing 36 gram of water and 46 gram of glycerine is. We have to find mole ratio, mole fraction. So how we will do it? That is moles of glycerine upon total moles. Let's find the moles and divide them. Now, what is the molar mass of glycerine? That is 92 upon what is given 46. Okay, so what we have Ng is zero point 0.5, and for water, what is given 36? Its mass is 18. It would be 2. Now we'll just divide it zero point 0.5 by zero point 0.5 plus 2, which gives us 0.5 by 2.5. Okay, and it comes out to be zero point 0.2. So the correct answer would be C. Now the next question says this is the reaction given to us and this is the del H. Now we have to find standard enthalpy of formation of NH3 gas in the above reaction. Let's see how can we find it. See, for 2 moles of formation, it is given to be 9 minus 92.4. So we need for NH3, that is 1 mole. What we will do? Simply we will divide it by 2. Okay. So it is equals to 1/2 of the value of enthalpy change. What will be the answer? Minus 46.2. Now the next question says the work done in ergs, this is a unit of work, okay? For reversible expansion of 1 mole of a gas from a volume of 10 liters to a volume of 20 liters, we have been given V1 and V2. Okay, we have this. So what formula we can use? We can use minus nRT ln V2 by V1, which can be written as minus 2.303 nRT log V2 by V1. Okay. For 1 mole is given, so N is 1. From this, we can make out that R would be 8.314. Temperature is given to us. We'll take it in Kelvin, which would be 298. V2 is known, V1 is known. So we'll just put the value. But one important thing that we need to do is we need to convert joule to erg. So for that, we use this expression. Okay. So we just substituted the values. This can be written as log 2 and this. So our final answer would be 2. Now, in the next question, what do we have? Statements are given and we have to select the following option. Statement 1 says for a complex reaction, order is given by the slowest step of the reaction. And this is correct, obviously. And statement 2 says molecularity of the slowest step is the same as the order of the overall reaction. See, for a complex reaction, we always take the order of the slowest reaction because the reaction and rate mainly depends on that step. Okay, but there's no linkage between statement 1 and statement 2. So it is definitely not explaining statement 1. So it would be B because molecularity of a reaction can be defined only for an elementary reaction. Because in complex reaction, what might occur like many of the reactants are reacting. In such high number molecularity, this chance is not possible. This is very, very rare. They can't be in state of encounter simultaneously. So this much cannot be there. That is why we say that the molecularity of the reaction can be 2, 3, and it's very hard even for 4. Now the next question says, sorry, which of the following statements is false? We have to say which one is false. First statement says rate law is an experimental fact, while law of mass action is theoretical. This is absolutely true. Rate law is more informative than law of mass of action for the development of mechanism. This is also true. We'll discuss why. Rate law is always different from the expression of law of mass action. Hmm. Note this word. This is false. Whenever you see such words, these are very strong words. Always, never. So always give them a benefit of doubt. So the answer would be C. Let's see how. What does rate law says? It says that the relationship between the rate of a chemical reaction and concentration of its reactants. Okay, the reactant's concentration. It is determined experimentally and can be dependent upon reaction mechanism. So now the law of mass action says, this law states that the rate of reaction is proportional to the product of the concentration of the reactants, each raised to the power of their stoichiometric coefficients. If we are raising it to the power of stoichiometric coefficients, that is, it is a theoretical concept. Okay, so we know why our statement 1 and 2 are correct. But why is the third wrong? Let's see. Rate law is always different from the expression of law of mass action. That is what is stated in the third statement. This is false because it may not always be different in some cases when the rate law match the law of mass action. In case of elementary reaction, they can be same. Okay. So that is the thing that we have to keep in mind. For statement 2, the rate law provides insights into the reaction mechanism, including order, which cannot be inferred by law of mass action alone. So these statements, I hope the answer is clear to you. Now the next question we have, this is the reaction given to us and the rate is given like this. Okay. Which of the following statements is true? Molecularity of the reaction is 1.5. Order of the reaction is 2. Molecularity of the reaction is 2 and order of the reaction is 1.5. See, what is given to us is K equals to H2 Br2 1 by 2, right? So this, supposing it is an elementary reaction, what will be the molecularity? The number of reactants taking part in the reaction, which is 2. And for order, what we will do? We'll consider it 1, right? Plus zero point 0.5. 0.5. 1 by 2 is zero point 0.5, so it will be 1.5. So the correct answer is 3 and 4. That is option D. Now, according to the next question, we have to consider the following statements and we have to see which of the option is correct. The first statement says the first order reactions, the rate of reaction is proportional to the first power of the concentration of the reactant. The first order of rate equation can be represented as this. All the natural and artificial radioactive decay of unstable nuclei taken place by first order kinetics. Okay, see. How do we write the reaction rate? Like this, whatever the reactant is, we raise it to that power, right? This is correct. And the first order, we know this expression. This is a very important expression even for your numericals. Okay. So what do we have here? K equals to 2.303 by T, R log R naught by R. That is true. All the natural and artificial, this is also true. Okay? All the natural and artificial radioactive decays take place by first order reactions. So all the statements are correct. See, rate of reaction is dependent on the concentration, this and this. I have now already explained this. So we'll move to the next question. What do we have here is the rate of the reaction quadruples, that is 4 times. When the temperature changes from 27 degrees Celsius to 57 degrees Celsius, two temperatures are given to us. Calculate the energy of activation. What formula, which formula we will use? We will use this Arrhenius equation. Okay. Log K2 by K1 equals to EA by 2.303 R, 1 upon T1 minus 1 upon T2. So we'll just substitute the values that are given to us. It quadruples, that means this 4 by 1, log 4 by 1. Okay. Because K2 would be 4. Initially it was K1, now it is 4 times of that. That is, we can write it as, initially it was K1, now it is 4K1. So it would be log 4K1 upon K1. That is log 4. Equals to EA upon 2.303 into 8.34 is already given to us. And we will substitute the temperature always in kelvins. Upon solving, we get this answer which will be converted to kilojoule per mole. Always notice the units given in the options. So the correct answer is C. Now in the next question, we have the rate constant for a first order reaction is this much. This is the rate constant. The time required to reduce 2 gram of the reactant to 0.2. First order is given. We'll use the equation, that is 2.303 by T into log concentration. Okay. So we'll just put the values log final upon log initial upon final. So what we get is 500 after substituting these values. Now in the next question, what do we have? In acidic medium, potassium permanganate. If it is acidic, it can be also written as this. Oxidizes the sulfide ion. Sulfide is this of PbS into, obviously it will be oxidized to sulfur. Okay. This is the balanced equation. So the correct answer would be sulfur. Now in the next question, we have this reaction. We have to say what is this. See, the breaking down of water is taking place. That is the decomposition. You can see hydrogen, and when we have oxygen, it broke into its constituent atoms or molecules. So it would be decomposition reaction. Now we have to tell which pair of embedded ligands is there among the following. This is NH3, this is monodentate, this is OH, this is also monodentate. Now NO2 negative, this is MB, wait, what is ambidentate? Let's see first. That is, it can use more than one of the atom for ligands, like for complexing. That is, in case of CN, we can use it through N or through C. NO2 is ambidentate. H2 is not. You can donate only like this. We can donate this and epsilon pair. SCN, yes, SCN is. It can do from here or here. So this would be the correct answer because this is also not. This is a bidentate ligand. So the correct answer is option 3. Now in the next question, what do we have? For which value of x and y, which of the following square planar compound shows geometrical isomers of P2, PLX, BRY to negative? We have to tell geometrical isomer. That is cis or trans. And when is it possible? When we have two of the same group. Okay, so now it's easy. It would be 2. So the correct answer is C. Cis isomer, where it would be adjacent and then opposite. Now, what is said in the next question? It is a very good question. It will test all your concepts. Which of the following statements is incorrect? I mean, Cl6 3 negative is more paramagnetic than MnCN6 3 negative. Let's see this. What is Mn plus 3? It is B4. Now, Cn is a strong field ligand, and Cl it is a weak field ligand. Okay. So, what happens here? Example, we have this situation T2G and EG. Hmm? If we have to fill D4, for Cn, there would be a stronger field ligand, that is the pairing. Firstly, these are occupied singly, you all know, right? And then for chlorine, what will happen? It will not be able to pair, so it will go like this. So it has 2 unpaired electrons and it has 4 unpaired electrons. Okay, and what factor does it depend? More the unpaired number of electrons, more will be the paramagnetism. Okay, so our first statement is correct that it has 4 unpaired electrons. It has only 2. So this is correct statement. Both CO, C2O4 3 negative and COF6 3 negative are paramagnetic. Now see, oxalate, this is a strong field ligand, whereas COF6 3 negative, in this F is a weak field ligand. Okay. So what will happen is that these will be paired in case of C2O4 and will not be paramagnetic. All of the electrons will be paired. This is incorrect. Now in the next statement, FeCN6 3 negative forms inner orbital complex and FeF6 forms outer orbital complex. Same concept is used. Cn is strong field ligand and Fe is weak field ligand. So what happens is we have 1, 2, 3, 4. So in case of Fe, this would be Fe3 plus. Okay. So it is D5. 1, 2, 3, 4, 5. After ligand, Cn, when Cn comes, it would be paired, right? So you see that 2 are empty and then we have P and S and P, whatever. So it is G2sp3, that is inner orbital complex. But in case of F, no pairing occurs. So the outer d orbital, we have d outer after this also. How do I take this? Yes, so it would be sp3d2. This statement is also correct, which is the incorrect statement now. That is B. So this would be our answer. Now in the next question, select the incorrect statement at equilibrium. Equilibrium is possible in closed system. Both the opposing processes occur at the same rate. This is obviously true. because if they are processing at the same rate, then only we can achieve equilibrium. Then all the physical processes stop at equilibrium. This is wrong. I'll tell you why. All the measurable properties remain constant, yes. See, the equilibrium never stops. It just undo the changes that are done. Okay, according to the Lee-Chatelier principle. Physical equilibrium is dynamic in nature. Both the forward and reverse process occur at equal rates. That is, there is always some kind of motion present. So this is incorrect statement. Now in the next question, what do we have for the following equilibrium? This is the equilibrium given to us. Kp is found to be 1.185. What is given? 1.185 at 400 Kelvin. Hence, partial pressure of NH3 and CO2 is asked. How we will solve this? Let's see. How will be the Kp of the given reaction expressed as? That is like this. It's written. Okay, for the products we have this 2 will come here and CO2 it's 1, so it would be 1. Now let us assume that the partial pressure for NH2 because it has 2, so it would be 2x, and for CO2 it would be x. Now we'll substitute in this formula. What do we get? We get this, which will be equal to 4x cube, which will be equals to, that is given to us, 1.185. So we'll find the value of x, that is 0.667. So for NH3 partial pressure was 2x, we'll just multiply and we'll get 1.3348, and for CO2 it was x. So the answer would be this, respectively, okay? First is NH3, then we have CO2. Now the next question is the hydrogen ion concentration in mole per decimeter cube in a zero point 0.2 molar solution of a weak acid HA is close to, we have to find the concentration here. See, what is given Kb. Now we have to note one thing. For a weak acid, alpha is very much less than 1. Now let us see. This is the reaction given. At time 0, we had our reactant and no product was formed. But after some time, what happened was we got alpha product. Let us suppose it was alpha, this much has been dissociated. And so it would be C minus C alpha, that, or we can write it as C1 minus alpha. Now, since alpha is very much less than 1, so Ka would just be C alpha square. Okay. Yeah. So it would just be C alpha square. Now what happens? Alpha, we can just substitute. If this is alpha, then it would be Ka upon C under root, right? Then for H positive, that was C alpha. That is, it would become C into Ka upon C. And now it will be Ka into C. So we know the expression now. We have to find K. How can we find Ka? We know that Kw equals to Ka into Kb. Kb and Kw are known. Kw is 10 raised to the power minus 40. So we have Ka now. We'll just substitute this, and zero point 0.2 will be taken from the quotient. We get the answer to be 2 into 10 to the power minus 3. Now, in the next question, what do we have? Which of the following will have the most negative electron gain and enthalpy? See, out of these, the answer would be 1. Why? Because when we will add electron to fluorine, it is already very small. If we are even adding even more electron, there will be electron internuclear repulsions. Okay, so that is why the electron gain enthalpy will not be that higher. And similarly would be the case of O2 negative. Okay. O2 negative. It has even more electrons. Its size is also small. So the repulsions would be there. So the answer would be yes. It will definitely take an electron. It is just one shot of electron. So if you will add an electron, it will surely take it. Now the next question we have, select the incorrect order of ionization energy. Hmm. What is the incorrect order of ionization energy? On what factor does the ionization energy depend? Let's see. It depends on half-filled and fully filled configurations, which is surely true, and SPDF for particular principal quantum number, if we have the same principal quantum number. So the incorrect order, Mg and greater than Al, this is correct. P greater than S is also correct, and greater than O is also correct. Obviously, this would be false because chlorine has a higher ionization energy than nitrogen because it is in the same period and it is size is even smaller. So Z effective will be more. So what is ionization energy? That is when we remove the electrons. So obviously it will be less. Here we have Al plus 3. It is, for example, saying it is plus 2. So we will consider the same configurations. Now we have this fully filled, okay? This would be different because it has 13 number, it has 12 number. So it will be easier for us to take the electron from this. Now let's see the next question. This is very easy. A gas X is used for filling balloons. Whenever you see filling balloons, obviously it's going to be helium, sorry. For the meteorological observations, it is also used in gas-cooled nuclear reactors. So which is helium. Keep this in mind. It is used in gas-cooled nuclear reactors. It is non-inflammable and light gas. Won't catch fire that easily. Now, the next question is chloride of an element A gave neutral solution in water. Which period would it be? It is chloride of an element A. So, obviously, we have a salt which is neutral. So, it should be from the first group. How? Let's see. We have M and Cl2. We got MCl. And then upon water, it had become MOH and HCl. Strong acid and a strong base. M is a metal, so it is neutral. So it should be of the first group. Then only we'll be able to. If it can look like this, we are forming a neutral solution. Okay, it should be chargeless. So almost same charge should be there. Chlorine is chlorine minus, so it is of the first group. It has plus charge. Now in the next question, hyperconjugation is not possible in the case of. See, in this mainly hyperconjugation is not possible. Why? Because it is at the bridgehead. It is near the bridgehead. So see here it is C. In hyperconjugation, alpha hydrogen electrons stabilize the structure, the carbon. Right? So here bridgehead carbon will never donate and will never take part in hyperconjugation, and here there is no hydrogen. So this is alpha, this is also alpha. So alpha hydrogen. It has no alpha hydrogen. So the answer would be B. Now the next question says IUPAC naming of this compound. We know how we will now name it. That halide will be named first here, and what the first would be written is according to the alphabetical order. It would be ethyl, then fluoro, then nitro. So what would be the name? It would be 4-ethyl 1 fluoro 2 nitrobenzene, which corresponds to option number 2. Now, in the next question, we have the intermediate in the electrophilic addition reaction of HBr to propene is. Let's see what is this reaction. We have propene and we have H plus from HBr. What happens is, in electrophilic addition involves the reaction of electrophile, in this we have HBr, with a nucleophile, that is the double bonded propene. So what happens is, here we will have a positive charge, that is a carbonation. Okay. Now we are negative, that is the nucleophile will attack, and this is the product we get. So what is the intermediate form? This is a cation. So answer would be 1. Next question says an alkyl group is derived from. See, what is alkane? This is, for example, I have C3H, for example, C3H, how should we take it? Let's take propane. So how will I have propyl group? That is CH3, CH2, CH3. It must be then formed and connected to another one, so it is propyl. What we did earlier, it had 8, now it has CH2. Now it has 7. Earlier it had 8, one less hydrogen. We remove the hydrogen from the saturated hydrocarbon. So answer 1. Unsaturated hydrocarbon means alkene or alkyne. But it is made from alkane. In the next question, the correct way of numbering the longest chain of carbon atoms containing the functional group is option 1. Carbon atom containing functional group should possess lowest possible number in chain. Obviously, this is correct. Lowest possible. If we have a functional group, it is always numbered first. Carbon atom containing larger carbon atoms should be chosen irrespective of the functional group. No, we choose functional. Carbon chain should exclude functional group. It should include functional group. So the answer would be 1. Now in the next question, it is given that a metal ion Mx plus has a spin only magnetic moment of 15 Bohr. Number of unpaired electrons is asked. Now we know that mu is equals to under root of n plus 2. Okay. So we can say that it equated to 15. This is what we get. So we'll just substitute the values here, and upon substitution we will get answer 3. That is, you see, 3 into 3 plus 2, 5, 15. Okay, so it is 15. Now in the next question, what do we have? The catalytic activity of the transition metals and their compounds is mainly due to, see, transition metal, what have they that other metals and non-metals doesn't have? Variable oxidation state, right? They can adopt variable oxidation states. That is why they can perform as catalysts. For example, you can see in the contact process, they are having variable oxidation state, and that is why we are using them as the catalysts. So the answer is C. Now in the next question, the possible oxidation states of titanium are. See, this is the configuration of titanium. So how many electrons could be removed? That is plus 2 obviously, and plus 3 and plus 4. This is what we can have. We take the possible oxidation state out of these. That is plus 2, plus 3 and plus 4. We are not asking what all can be, okay? What is given in the option, we have to select according to that, the most appropriate one. Now in the next question, the synthesis of alkyl fluoride is best accomplished by? See, if I need to synthesize alkyl fluorides, it is given in your NCRT. We use Schwartz reaction, in which we take any alkyl halide, for example, CH3Br, and we take AgF, or we can take other ones also. I guess it was HCA2F2 also. Then we have CH3F plus AgBF. So it is Schwartz reaction. Now, in the next question, you will see you have to match the following. In column 1, we have been explained the structure, and in column 2, we have to match them. It says a halogen atom is bonded to an sp3 hybridized carbon atom next to an aromatic ring. So let's draw an aromatic ring first. And it is said halogen is bonding to a sp3 carbon, that is this. This is sp3, right? This is sp2. So this, what is this group? This is benzylic group. So it would be 3. Now, halogen atom is bonded to an sp2 hybridized carbon atom. So carbon-carbon double bond. That is this. Or maybe this. Okay, that is allylic or vinylic, directly attached. Allylic is different. It is this. So this is vinylic. So now last one, halogen is attached sp2 of the ring. This is sp2. This is aryl halide. Okay. So the answer would be 3. This is benzylic, this is vinylic, and this is aryl. Okay. So, in the next question, we have which of the following molecules is achiral? That is, we have a carbon and it has different groups altogether. It has no same group. That is, now we have two chlorobutane, C, 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 C here and C. Now you can see that it has, this is chiral, right? 2 comma 2 dichlorobutane. Let's take 2 comma 2 dichlorobutane. It is this. This is C. Now we have same atoms. So we have this as our answer. And when it was written bromochloroiodomethane, so these are also different. See, bromochloroiodomethane. 2-bromobutane would be same as this. This won't be there. It would be Br. That is the correct answer. Now in the next question, consider the following alkyl halides. See, ethyl group is same. What is different is this. We have to tell that statement 1 says one undergoes faster dehydrohalogenation than 2 and 4. 3 undergoes lower dehydrohalogenation than 1, and 4 has the least stability to undergo dehydrohalogenation. See in dehydrohalogenation, the bond is breaking. So bond length should be large. It will easily break, right? So in case of chlorine, bromine, and iodine, bond length increases in this order. So it would be a better leaving group. So I, Br, Cl, and F. The reactivity for dehydrohalogenation will be in this order. Now let's see. 1 undergoes faster dehydrohalogenation than 2 and 4. This statement is absolutely correct. That I is undergoing faster than 2 and 4. Now in the next statement we have 3 undergoes 3 undergoes lower dehydrohalogenation than 1, which is also true. Now 4 has a least stability. This is also true. So all the statements are correct. That is option A, B, and C. The last question of the day. We have the hydrocarbon is C5. H10 does not react with chlorine in darkness, but under bright sunlight it yields one single monochloroproton. That is C5H9Cl. Identify the hydrocarbon C. This is CnH1, which can correspond to cycloalkane or an alkene, right? But it says that hydrocarbon does not react in chlorine with dark, which means this is not alkene. It will not be reacted in dark. So it is obviously cycloalkane. And 5 is for pentane. So it is cyclopentane. Right? Let's see the reaction. All of these are equivalent. Then only it can form monochlorinated product, right? So in bright sunlight, and this will be the product that we get. That is chlorocyclopentane. I hope all the questions are clear to you. Thank you and let's meet in the next video.